Welcome to a Gobbet Opus, number 4, from September 10th, 2008, Genetics and Infection. Let's start with a quotation to show how erudite I am. The fault, dear Brutus, lies not in our stars, but in ourselves. That was Edward de Vere, the Earl of Oxford. I do not necessarily want to blame the patient, but someone has to be at fault when things go badly. I've always had a policy of blaming nursing when things go wrong. But now it is the genome where all that action is. This century has been filled with many advances in the understanding of the role of polymorphisms in the host immune system and the subsequent risk of infections and varying outcomes of various infections. We've always known that not everyone is immunologically identical, any more than we have the same height or hair color or sense of humor. Why some people live, why some people die, besides using alternative medicine. Why some people get an infection and others do not has always been a mystery. Certainly there is variability in the virulence of different strains of, say, E. coli. The variation in the morbidity and mortality that you see clinically seems to be more than can be accounted for by variations in the organism. In outbreaks from the same strain of pathogen, there is always variability in the effects upon the host. Not all people have the same predilection to infection. I really should be a rapper. Or the ability to withstand an infection. A 65-year-old diabetic with lupus on prednisone just isn't going to do as well with a bloodstream infection as a young, healthy person. But the gross assessment that sicker people do worse with infection never seems to be enough to account for the great variability that you see clinically in the outcomes of disease. What is increasingly clear is that there are often small but profound changes in the genes that may determine whether we live or die from infections. Genes, as you know, code for proteins. They also code for proteins. There can be single mutations in the genes, normal variations, and these are called polymorphisms. Your gene that codes for a protein is not always identical to the gene that I have. Your gene may make more of a protein or less of a protein, or one with greater or lesser affinity for its substrate. These variations are some of the clay upon which evolution molds its change. Remember, I have a degree in metaphorableness, but some genetic polymorphisms can make you more or less susceptible to getting or dying from infections. Take mannan-binding lectin, please. Anyone listening here know who Henny Youngman was? Anyway, I will quote the Wikipedia here, and I always get the urge to sound like Queen Victoria when I do, but I will not this time. The mannan-binding lectin pathway, also known as the Ali-Kruger pathway. That was a great fight, wasn't it? Ali-Kruger, I think it was 1968, third-round knockout. Is homologous to the classical complement pathway. This pathway uses a protein similar to C1q of the classical complement pathway, which binds to mannose residues and other sugars in a pattern that allows for binding on multiple pathogens. Mannan-binding lectin, MBL, not to be confused with Major League Baseball, or Major Baseball League, is a protein belonging to the colectin family that is produced by the liver and can initiate the complement cascade by binding to pathogen surfaces. MBL is a 2 to 6-headed molecule that forms a complex with MASP1, which of course means the mannan-binding lectin-associated serine protease, and MASP2, two protease zymogens. MASP1 and MASP2 are very similar to C1R and molecules of the classical complement pathway and are thought to have a common evolutionary ancestor. When the carbohydrate recognizing heads, which I believe was David Byrne's first band, of the MBL bind to specifically arranged mannose residues on the phospholipid bilayer of a pathogen, MASP1 and MASP2 are activated to cleave the complement components C4 and C2 into C4A, C4B, C2A, and C2B, or not 2B. That is the question. C4B and C2A combined on the surface of the pathogen to form C3 convertase, while C4A and C2B act as chemoattractants. Say what? What this says is that bacteria have on their outside a variety of sugars, including a sugar called mannose, and that the mannan-binding lectin is a protein that recognizes these sugars and activates a wing of the immune system called the complement cascade to pop that bacteria like a balloon and to help bring in the white cells for the final kill. Cool. Another wing of the immune system that cannot be boosted, but can have mutations that render the patient at risk for infection. There have been a few studies that have shown that a decrease in mannan-binding lectin is associated with an increased risk of infection, but an interesting study was published in Clinical Infectious Diseases in August of 2008. In the study, they found that polymorphisms that lead to decreased serum levels of mannan-binding lectin led to a twofold increase in death from pneumococcal bacteremia. 25% of them what had low levels died versus 12% of them what didn't. Pneumococcus is one of many kinds of streptococci, one of the more common pathogens in humans and in other animals as well. Your genes may be different than mine, and that may make the difference. The threads that keep us alive are often thinner than we know. All well and good, but what makes it all the more cool is the accompanying editorial. Quote, 565 million years ago, when the world was empty and barren because... I'm not going to do that. 565 million years ago, when the world was empty and barren because animal life had not yet colonized the land, a common ancestor that we share with sea squirts inhabited the seas. One of the genes that we still share with the sea squirts today, seashells by the seashore, is a gene for mannose-binding lectin, signifying that this gene has existed for 565 million years and thus has been highly conserved throughout animal evolution. The fact that our ancient ancestors, the sea squirt, and us, humans, all have to protect ourselves from streptococci and use the same defense mechanism I find particularly satisfying. The connections between infections, you see, I need to be a rapper, and the host response, one of the more compelling lines of evidence of evolution, and yet another reason that infectious diseases is the coolest specialty in all of medicine. The relevant reference for this podcast was low serum mannan-binding lectin increases the risk of death from pneumococcal infection, Clinical Infectious Diseases, 2008, Volume 47, page 510. See you next time.